Hello my dear students and my dear friends. We are in the chapter Quadratic Equation. Today we have taken exercise 4.1. In this video let us see how many questions we can complete. Here we have taken the first question. Let us read the question. Form a quadratic equation with the following roots. Okay. Here there are 6 questions, 6 subparts or 6 bits here. Okay. Now here these are the roots and we have to frame the quadratic equation. These sums can be done in many ways. Okay, let us see some methods. Okay, number 1, here in the first case the roots are -5 and 7. One method we can apply is that, what is the formation of a quadratic equation? X square minus sum of roots into x plus product of the root equal to 0. This is one form. And another method, that is x minus first root x minus second root is equal to 0. Now I'll show in the first sum, I'll show both the methods, then you will decide which method is suitable for you. Alright. Okay, so here let us take sum of the zeros. Sum of roots. Zeros we say in quadratic polynomial. Sum of roots equal to -5 plus 7, which is equal to 2. Product of roots equal to -5 into 7, it is -35. So the required quadratic equation is x square minus sum of roots into x plus product of roots equal to 0. Alright, x square minus, what is the sum of the roots? 2, twice x plus -35 is equal to 0. Or directly also you can write this final result without writing this, x square minus twice x plus minus -35 is equal to 0. Now, or another method. Okay, directly you can do a required quadratic equation is, you will write like this. You can write x minus this, x minus of this, so minus plus into x minus 7 is equal to 0. This is another form. So now you multiply, you will get the answer. X into this, x square minus 7x, then with 5 we shall multiply, 5x minus 35 is equal to 0. So it is x square, if we add them, this is minus twice x minus 35 is equal to 0. Now you can check these two, the quadratic equations are same. Alright, now let us go for the second one. Now let us do the second one. Here let us apply the first method only. This is also very easy method. Okay, here sum of roots equal to -half minus 3, 2 minus 1 minus 3 to just 6, so -7 by 2. Product of roots -half into -3, which is equal to minus plus 3 by 2. So the required quadratic equation is x square minus sum of the roots into x plus product of the roots is equal to 0. Alright, now let us substitute the values. X square minus, it is -7 by 2 into x plus product of roots is 3 by 2. What we'll do, we'll take the LCM. What is the LCM? 2 into x square, twice x square, minus plus, this is 7x, this is 3 is equal to 0. Cross multiply, what will obtain? 2x square plus 7x plus 3 is equal to 0. This is the required quadratic equation for second one. So we have completed 1 and 2. Now let us move for third one. Now in third one, sum of roots is 1 plus minus 3 by 2. LCM 2 plus minus 3, this is minus 1 by 2. This is the sum of the roots. Then let us find product of roots. Product of roots. Let us multiply 1n minus 3 by 2. It is minus 3 by 2. So now let us frame the quadratic equation. So the quadratic equation is x square minus sum of the roots into x plus product of the roots is equal to 0. So x square minus, what it is, minus 1 by 2 into x plus product of the roots minus 3 by 2 is equal to 0. Let us take the LCM. What is the LCM? 2. So 2 into x square, 2x square, minus plus 2 by 2, 1, 1 into 1, this 1x, that is simply x, plus 2 by 2, 1, 1 into minus 3 is equal to 0. Cross multiply. Here it is 1. So this into this, same thing, 0 into 2 is 0. So the quadratic equation becomes 2x square plus x minus 3 is equal to 0. Alright, now let us move to number 4. Again the same procedure. Sum of roots 1 plus minus 4 by 5. What is the LCM? 5. 5 into 5 plus minus 4, 1 by 5. Alright, sum of the roots is found. Next, what will find? Product of the roots. These are very easy sum, is not it? Product of roots. This into this, 1 into minus 4 by 5. How much it is? Minus 4 by 5. Got it. Okay. So the required quadratic equation is x square minus sum of the roots into x plus product of the roots equal to 0. X square minus sum of the roots 1 by 5 into x plus product minus 4 by 5 is equal to 0. Now what we'll do, we'll take the LCM. What is the LCM? 5. So 5 into x square, 5x square minus 1x minus 4 is equal to 0. Cross multiply. So it is, equation will be 5x square minus x minus 4 is equal to 0. Alright. Now we have to move number 5. Okay, this is also very simple. Sum of roots half plus minus 1 by 3. LCM 6. 3 plus minus 2. Okay, 1 by 6. Product of roots half into minus 1 by 3. How much it is? Plus minus 1 by 6. Alright, so the quadratic equation is x square minus sum of the roots into x plus product of the roots is equal to 0. X square minus sum is how much? 1 by 6, sorry, plus product is minus 1 by 6 is equal to 0. We'll take the LCM. LCM is 6, so this is 6x square minus x minus 1 is equal to 0. What we'll do? Cross multiply. Here it is 1. Denominator is 1. So this into 1 is same. 0 into 6 is 0. 6x square minus x minus 1 is equal to how much? 0. Alright. Now dear students, we have just completed question number 5. Now let us move to number 6. Here sum of roots is how much? 5y plus minus 5y. They are equal and opposite, so it is 0. Product of roots, we shall multiply them 5y into minus 5y. Okay, plus minus 5 into 5, 5 into 5, 25. I into I square. Now what is the value of I square? You know it. I square is equal to minus 1. So minus 1 into this minus 25 is plus 25. Alright. So the quadratic equation is x square minus sum of roots into x plus product of roots equal to 0. X square minus s is how much? Sum is 0. 0 into x plus product is 25 equal to 0. So it is directly, you can write this line, you can write directly. So thus we have completed the question number 1. Alright. Now dear students, here in question number 2, let us read the question. Form the quadratic equation whose one root is this. This is a special case of the formation of a quadratic equation. The solution, whatever we will do, this is not always true in all the cases. This is a special case. When we will get this special case? Only in 2 cases. One is the roots are irrational numbers. Irrational, this is one case, or if the roots are complex or imaginary number. Okay, if the roots are irrational and if the roots are complex numbers or imaginary number, then only we will get this special case, not always. Suppose one root is 2. Okay, this is a real number, but this is not any complex number. So here, if one root is 2, we cannot say that what is the other root. But if the case is one root is suppose 2 plus root 3, it is sure that the other root will be 2 minus root 3. That means its conjugate. If one root is 4 minus 2 root 3, other root must be 4 plus 2 root 3. And in case of complex number, if the roots are imaginary, suppose one root is suppose root 2i, the other root must be minus root 2i. Okay, this should be the conjugate of this. If it is plus, it is minus. If it is minus, this should be plus. You know the conjugate, about the concept of conjugate. Okay, let us do number 1. Let us solve it. Okay, here the two roots are one is, if one is root 3i, what is the other one? Other one is minus root 3i. Okay, now let us frame the sum of roots, root 3i plus minus root 3i. This is I. Okay, it is 0. Then product of roots, let us multiply them. Alright, so root 3i into minus root 3i. So this is minus, plus minus minus, root 3 into root 3, 3, I into I square, minus. Okay, now you see here, what is the value of I square? I square is minus 1. Minus 1 into minus 3 is plus 3. So the required quadratic equation is x square minus sum of the zeros into x plus product of the zeros. Directly we are writing here. In this time we are not writing the formula or the format. So x square plus 3 equal to 0. This is the required quadratic equation. Alright. Now in second case, the two roots are they should be conjugate. The roots are conjugate. If one is 4 plus root 5, what will be the other one? 4 minus root 5. Alright. Now, so sum of roots, let us add them. 4 plus root 5 plus 4 minus root 5. Okay, root 5 will get cancelled. 4 plus 4, 8. Then product of roots, let us multiply. 4 plus root 5, 4 minus root 5. This is of the form a plus b into a minus b, which is equal to a square minus b square. 4 square is 16, root 5 square is 5. This is 11. So the required quadratic equation is x square minus sum of zeros into x plus product of the zeros, product of roots. I think zeros, these are product, this is sum of the roots, this is product of the roots. So the required quadratic equation is, in this case, x square minus 8x plus 11 is equal to 0. Alright. Now in third one, at first let us simplify. This irrational number is not simplified like this. So here what is this? 2 plus 1 by 2 plus root 3. Let us rationalize the denominator. 2 plus root 3. So how we do this? We shall multiply this by 2 minus root 3. This is also 2 minus root 3. So 1 into this 2 minus root 3, a square minus b square. So this is 2 minus root 3, 2 square 4, 3. Okay. So this is denominator will be 1, 4 minus 2, 1. So directly let us write 2 minus root 3. So the two roots are, what are the two roots? One is 2 minus root 3. And what will be the other root? Its conjugate. What is the conjugate of it? 2 plus root 3. So now let us find sum of the roots and product of the roots. Sum of roots is equal to, let us add them, 2 minus root 3 plus 2 plus root 3, root 3 cancel, it is 4. Product of roots, let us multiply this into this, 2 minus root 3, 2 plus root 3. Okay, this is of the form again a minus b into a plus b. Okay, what is their product? A square minus b square. 4 minus 3 is equal to 1. Now let us frame the quadratic equation. So the required quadratic equation is x square minus sum of roots 4x plus product of the roots 1 is equal to 0. Right? Then in number 4, again same thing. Here the two roots are, they will be conjugate of each other. One is 1 minus root 3 by 2i, and what will be the conjugate of this? 1 plus root 3 by 2i. So let us find the sum of the roots and the product of the roots. Sum of roots, let us add them. 1 minus root 3i by 2 plus 1 plus root 3i by 2. These two will get cancelled, so 1 plus 1 is 2. Then product of roots, let us multiply them. Okay, this into this, 1 minus root 3i, this is root 3i into 1 plus, this is root 3i by 2. Again this is of the form a minus b into a plus b, isn't it? So this is, you know it how to do, a square minus, this is root 3i by 2 square. So then this is 1 square 1. Now here dear students, you see root 3 square is 3. Okay, then I square 2 square is 4, 1 minus, okay, this 3. What is the value of I square? I square is minus 1. I am showing all the steps. 1, this is minus 1 plus 3 by 4. Okay, so it is 4 plus 3. This is 7 by 4. So we have found the sum of the roots and the product of the roots. So the required quadratic equation is x square minus sum of the roots is how much? 2, x plus product of the roots, it is 7 by 4. Now to simplify this, what we'll do, we'll take LCM. What is the LCM? 4. So 4 into x square, 4x square minus 4 to the 8x plus 7 is equal to 0. Okay, got it. Then let us do the cross multiplication. So the equation becomes 4x square minus 8x plus 7 is equal to 0. Alright. Then dear students, let us move to number 5. Here the two roots are, we have to take their conjugate. One is minus 1 minus root 5 by 2, and what is the conjugate of this? Minus 1, then it is minus root 5, so it will be, next one will be plus root 5 by 2. Okay, thus we have written the two roots. Now what we'll do, we'll find their sum and the product of the roots. Sum of roots, minus 1 minus root 5 by 2 plus minus 1 plus root 5 by 2. Take LCM. Let us take this LCM. It is 2. So minus 1 minus root 5. Then this is plus minus 1 plus root 5. So this 2 will get cancelled. Minus 1 minus 2 by 2 is minus 1. Product of roots. Product of roots. So this is minus 1 minus root 5 by 2 into minus 1 plus root 5 by 2. Got it? Okay, so this is in the numerator. This is again in the form a minus b into a plus b, which is equal to a square minus b square. Okay, 2 to the 4. 1 minus 5 by 4 minus 4 by 4 is minus 1. 1 minus 5 is minus 4 here. So thus we have found the sum of the roots and the product of the roots. What is left? To find the quadratic equation now. So the required quadratic equation is okay, x square minus sum of the roots minus 1 into x plus product of the roots minus 1 is equal to 0. Let us simplify it. This will be the last step. Minus minus plus 1x, or simply x, plus minus minus 1 is equal to 0. Got it? Then we are in the last one, number 6. Okay, this is also very simple. Here the two roots are p plus p square minus c. One is this, and what is the next one? Obviously its conjugate. What is the conjugate of this? P, and it will be then minus root over p square minus c. Again, initially I have said this is a special case. This is a case when we get the roots are either irrational or complex number or imaginary number. Okay. If one root is given 2, never take that the other root is minus 2. Please don't do this mistake. Here we are not discussing this case. This is a special case. Okay. So please try to understand this concept. Okay. Here do not take 1 is 3. Next root is minus 3. It is not that case. If one root is 1 by 4. Next root is not minus 1 by 4. This concept is wrong. Here we are doing for imaginary and the complex number. And irrational number. Okay, so here we have written the two roots. Let us find the sum of roots. P plus root over p square minus 7 plus p minus p square minus c. This two will get cancelled. P plus p twice p. Got it. Next, product of roots. So this is p plus root over p square minus c, p minus root over p square minus c. You see, they are in the form a plus b into a minus b. So which is a square minus b square. So this is p square minus, the square root will be removed. So what will be left here? P square minus c. So p square minus minus plus c. So only c is left. Now, so the required quadratic equation is x square minus sum of the roots twice p into x plus product of the roots 0. Got it? My beloved students, now we have taken question number 3. Here the question is, find a quadratic equation whose roots are, now there are 3 subparts. And the first part is 2 less than the roots of this. We have to frame or find a quadratic equation whose roots are, each root is, that means 2 less than the roots of this. So here what we will try to do, this sum can also be done in many ways, many methods. So let us take 2 methods. The first sum I will do by one method, and second and third let us try with another method. Let us see. Then at the end you will decide which method is suitable for you. Okay, here in the first case, let us find what is the roots of this. X square minus 16x plus 63 is equal to 0. Let us find the roots by how? Middle term splitting. Okay, so x square minus 63. So it is 63, 3, 2, 1, 3, 7. So 9 plus 7. So this is directly I am doing one line only, I am skipping. Directly also I can do this. Okay, here if I am to do here, it will be x minus 9, x minus 7 equal to 0. In this way also we can write, but you need little bit practice. Okay, so here it is x square minus 9x minus 7x plus 63 equal to 0. Okay, so let us make a pair. In the first pair, what is common? X minus 9. Here minus 7 is common. X minus 9 equal to 0. Here x minus 9, x minus 7 is equal to 0. Okay, let us wrap this. This is not required at all. So the two roots are, okay, here either or we have to do. Either x minus 9 equal to 0 or x minus 7 equal to 0. So this is x equal to 9 and this gives us x equal to 7. So two roots are, what are the roots? 9 and 7. Okay, now we have to frame a quadratic equation, isn't it? Whose roots are 2 less than the roots of this. So these roots are 9 and 7. So what will be the roots of the required quadratic equation? So the roots of the required quadratic equation are, what are the roots? Each root will be less by 2, so that is 9 minus 2, 7, and here it will be 7 minus 2, 5. Each root is 2 less, that means 9 minus 2 and 7 minus 2. So the required quadratic equation is x minus 7 into x minus 5 equal to 0. Can you multiply directly? Okay, let us solve by showing all the steps. X square minus 5x minus 7x plus 35 is equal to 0. X square minus 12x plus 35 equal to 0. In this way we have solved this. That means where that each root is 2 less than the root of this. Okay, now let us try this number 2 and number 3 with another method. Now let us move to number 2 here. The roots are, we have to again frame a quadratic equation whose roots are greater by 4 than the roots of this. Here in the first question the roots are 2 less, here greater by 4. If you want, if you wish, you can do by the same method, no problem at all. But I want to show another method, because there are different types of students, so different views are there. Someone will say, sir, I like this method, someone will say this method. One method I have shown you, actually that is the easiest method. Then another by standard method let us do. Here one, before starting this, the standard form of a quadratic equation is ax square plus bx plus c equal to 0. Here there are two roots. Here you know that sum of the roots is given by minus b by a and the product of roots is given by c by a. This thing you have got in quadratic polynomial also in general mathematics. Okay, here sum of the roots minus 13 by 1, that is minus 13. Product of the roots, it is c by a, 5. Now here for the quadratic equation, for the required quadratic equation, sum of roots, each root is increased by 4, greater by 4. That means here one root was alpha and another root was beta. Then now one root will be alpha plus 4 and another will be beta plus 4, because it is a greater by 4. Each root is greater by 4. So alpha plus beta, let us write together, and 4 plus 4, 8. Now what is the value of alpha plus beta? This is minus 13 plus 8, this is minus 5. Then product of roots, this are we are finding for the required quadratic equation. Product of roots that is, these are the two roots now, alpha plus 4, beta plus 4. Let us multiply. Alright, alpha beta plus 4 alpha plus 4 into beta, 4 beta plus 4 into 4, 16. Now here let us write one more step. Let us take 4 common. Alright, from these two, alpha plus beta plus 16. What will be left? Alpha into beta is 5. 4 into alpha plus beta is minus 13 plus 16. Okay, this is very easy for us. 5 plus minus minus, 4 into 13, 52, then plus 16. 5 plus 16 is 21, minus 52. So let us subtract this, orally also you can do. This is minus 31. Alright, so now let us frame the quadratic equation. So the quadratic equation is x square, okay, then minus sum of the zeros, minus 5x, plus product of the roots. I said zeros, I am sorry, today I am only saying 0 0 0, actually these are roots. Minus 31 is equal to 0. X square minus minus plus 5x minus 31 is equal to 0. This is the required quadratic equation for this. Alright, now let us do the third one. Again let us read the question. Find a quadratic equation whose roots are reciprocal of the roots of this. So here the given quadratic equation is, okay, this is number 3. We have to write the number 2x square minus 7x plus 6 equal to 0. Here what is the sum of the roots? This is minus b by a minus b by a. So this is 7 by 2. Product of the roots c by a is equal to 3. Okay. Now for the, let us find, we have to find a quadratic equation, isn't it? So for the quadratic equation, what is the nature of the roots? Reciprocal of the roots of this. So to get the required quadratic equation, what we have to do? We have to find again sum of the roots and the product of the roots. So let us find that. For the required quadratic equation, we have sum of roots. What are the two roots now? The reciprocal. Earlier the roots are alpha and beta. Now the roots will be 1 by alpha and 1 by beta. So the sum will be 1 by alpha plus 1 by beta. Alpha, LCM is alpha beta. So it is alpha beta by alpha beta, beta into 1 beta. Alpha beta by beta is alpha into 1 alpha. Okay, beta plus alpha is 7 by 2. Alpha beta is 3. So this 7, 2 will come here, 2 3 is 6. Okay, I hope you understood this. Then product of roots. The roots are 1 by alpha into 1 by beta. So the product is like this, 1 by alpha beta. Alright, so product becomes 1 by alpha beta. What is the value of alpha beta? It is 3. So the required quadratic equation is x square minus sum of the roots 7 by 6 into x plus product of the roots 1 by 3, 0. Let us simplify. What we will do? We will take the LCM. The LCM is 6. 6x square minus 6 by 6, 1 into 7, 7x plus 6 by 3, 2 into 1, 2 is equal to 0. Cross multiply. 6x square minus 7x plus 2 is equal to 0. Alright, my beloved students, we are in question number 4. Here there are two parts. We have taken the first one. Let us read the question. Here question is find the value of k such that one root of this is twice the other. Suppose one root is 3. What will be the other root? 6. One root is 5. Other root will be 10, like that. Okay. So here the quadratic equation is 2x square minus 5x plus k equal to 0. Here this is one part, number 1. There is another one, number 2. This is very short and that one is lengthy. That's why we will take in next time. Okay, so here let the two roots be, what is said, one root of this is twice the other, one root is alpha and next will be twice of this, twice alpha. Got it? Two roots be there, one is double of this, is twice. Okay, so here let us find that sum of the roots alpha plus twice alpha is minus b by a, minus b by a. So this is thrice alpha is how much, minus 1 plus 5 by 2. So alpha equal to 5, this 3 will come, so 3 to is 6, alpha is 5 by 6. Got it? Okay, again then product of this, product of the roots alpha into twice alpha is c by a. What is c? K, c by a. Our aim is to find the value of k. So this is 2 alpha square is equal to k by 2. 2, what is the value of alpha? 5 by 6, its square, k by 2. So this is 2 into this is 25, 36 is equal to k by 2. Okay, now this is 2 into 25 by 36. 2 is divided, in this side it will be multiplied, into 2 is equal to k. So let us 2 to the 4, 4 9 ja 36. So k equal to 25 by 9. Got it, my beloved students? Now this is the number 2 of question number 4. Here the question is, let us read the whole question. Find the value of k such that these two equations have a common root. Okay, now dear student, here before starting this we should have some idea. Actually in the chapter linear equation in two variable in general mathematics, you did one process that is called cross multiplication method. Can you remember this? Okay, let us recapitulate for some time. Here there are two equations. Suppose a1x plus b1y plus c1 is equal to 0. Another one is a2x plus b2y plus c2 equal to 0. Now how do we solve this? By the method called cross multiplication method. I will teach you another method. You may find this is easier than what you have learned. At first what you write? You write the coefficients of x and y and the constant terms. What are the coefficients? a1, b1 and c1. Again here a2, b2, c2. Here directly we have written the coefficient, but in the book or somewhere in all the videos they have started with this. But my method is at first a1, a2, b1, b2, c1, c2. Then again you close with this one. We have started with a1, a2. Again we shall close with a1, a2. You see, we have started with a1, a2, a1, a2. Again here a1, a2. Now what is x and what is y? How do we find x and y directly? Okay. Now when you will find x, you hide these coefficients, multiply this, cross multiplication, this into this, minus, always in the middle there will be minus, and b1 into c2, b1 into c2 minus b2 into c1. Got it? Then in the second case y, these are the coefficients of y, so hide them. Now you cross multiply here, c1 into a2, c1 into a2 minus c2 a1. Now we'll say, sir, the denominator in each case is left. Yes, this part is also left, that's why denominator is left. So here we will multiply a1 into b2, a1 b2 minus a2 b1. This is a2. Okay, now they are also copy paste, a1 b2 minus a2 b1. In this way, this is how we can solve x and y by the method of called cross multiplication method. Okay, this same concept we shall apply here. Okay, so before starting, let us wrap this part. Now let us solve it. Here we have to find the value of k. They have a common root. Now let us consider, let alpha be the common root. That means this is a quadratic equation, it has two roots. This is another quadratic equation, it has another two roots, but one root is common. Suppose one root is 2. Here for this quadratic equation, suppose two roots are, some of you may have doubt, what is this common root? Suppose it has roots, suppose 2 and 3. It has two roots, suppose 2 and 5. This 2 is common. Okay, that is the thing is said here. So let alpha be the common root. Now, if 2 is one root here, if you can substitute in place of x equal to 2, the right hand side will be always 0. Here, if you put this 2 here, right hand side is always 0. So we have here twice k minus 5. In place of x we are writing alpha because alpha is a root, minus 4 alpha minus 15 is equal to 0, and that is 3k minus 8 alpha square minus 5 alpha minus 21 equal to 0. Now let us solve this. How will solve? The method which we have discussed, that is cross multiplication method. Here what we'll write? We'll write the coefficients of alpha square and alpha. Here let us write the coefficients. What are the coefficients here? Twice k minus 5. Here it is minus 4. Constant term minus 15. Here 3k minus 8 minus 5 minus 21. We will end or close with this twice k minus 5 and thrice k minus 8. So these are the coefficients of alpha square. These are the coefficients of alpha, constant term. Okay, so at first like this, here we will find alpha square. What is alpha square? When we will find alpha square, then we shall hide them. Why? Because these are the coefficients of alpha square. So let us multiply these two. This into this, so minus minus plus, this is 84. In the middle minus 5 into this, 5 15 is 75. Okay, then we shall find alpha. What is alpha? Here these are the coefficients of alpha, so we shall hide them. We will multiply these two. Minus 15 into this, what is this? 3k minus 8. In the middle minus sign, so this into this, obviously that is minus. This minus into minus is plus, so 21 into this, 21 into what is this? Twice k minus 5. All right, here we need little bit patience. Now here in the denominator we can fill up by this into this into this. So minus 5 into twice k minus 5 minus this into this, there is minus sign, so it will be plus 4 into this, 4 into 3k minus 8. Here let us do the same thing here, same thing let us write. What it is? Minus 5 twice k minus 5 plus 4. Okay, this is 5, this is then 4 into what is this? 3k minus 8, 3k minus 8. Okay, let us simplify a little bit. So this is 84 minus 75 is 9. Okay, then minus 10k, then plus 25 plus 12k minus 32. So this is 9, this is 2k, then this is minus 7, this is 7. All right, okay, let us write nicely 7. Got it. Okay, here let us simplify it. Here minus this is 45k plus 120 plus this is 42k minus this is 5 1 is 5, 5 2 is 10, 105. And this one is same thing, so directly let us write. Okay, we will not do these steps directly because its value is this and they are same. This is twice k minus 7, twice k minus 7. So let us simplify this. For this is minus 3k, this and this like terms, minus 3k, and 120 minus 105 is plus 15. Okay, this is twice k minus 7. Now from here we can take what is common here. Suppose 3 is common, 3 is, let us take this 3 is common. Okay, so what will be left? Minus k, then plus 5. Okay, 3 is taken common, so what will be left? Minus k plus 5, and then in the denominator twice k minus 7. So here we have found the expression for alpha square is this and expression for alpha is this. How will solve? Here we shall substitute the value of alpha. Here in alpha square means alpha this square. So we'll make it square here. Okay, in the next step. Now, dear students, we have written the expression for alpha square here and the expression for alpha. What we'll do? The step is very simple. Here alpha square. So let us write this term 3 minus k plus 5 divided by twice k minus 7. What we have to do is we have to make it square. So it's square alpha square, this is alpha and its square, alpha square is written, very simple thing, 9 twice k minus 7. Okay, so this is 3 square is 9 minus k plus 5 whole square. This is also like this. Suppose a term is like this, a b c its square. How will write? A square, b square, c square. So its 3 square is written right here, 9 is written, its square is written, its square we shall write twice k minus 7 square, 9 twice k minus 7. Now a little bit we can simplify here also. What will do? 9 cancel. Okay, so what will be left in the numerator? Minus k plus 5 square. Got it. And here there is 2k minus 7 and its square. So one term let us remove. Let us cancel. So what will be left here? Twice k minus 7. Okay, so here this 9 is cancelled, this is cancelled. So in this side only 1 will be left. Again I am discussing this, explaining. 9 is removed, 9 cancel. 2k, okay, here like this. Suppose something is there, suppose 9 is there, all right. 9m, suppose anything, and here it is suppose x and it is x square. So if we remove this x, only one x will be left. If we remove this 9, 1 will be removed, like this. Same thing is here. So what we do, let us cross multiply. It is minus k plus 5 whole square. 1 into this is twice k minus 7. All right, we are very close to find the value of k. This is of the form a plus b whole square. So this is a square plus twice ab plus b square. This is twice k minus 7. So this is k square minus 2 5 10k plus 25. Let us bring everything this side. Minus 2k plus 7 is equal to 0. So it is k square 10 minus, this is minus 10 minus 2 minus 12k, this is 32 is equal to 0. You do the middle term splitting. Here I want to do directly. Can you do directly? Let us try one. You see how we'll do. Here we have to get minus 12 and here their product is 32. Which are the two numbers whose product is 32 and their sum is 12? Minus 4 and minus 8, because minus 4 into minus 8 is 32. Only one sum I am doing directly. Okay, you can do, if you find this method is hard, please do the middle term splitting and at the end you will get this result. What you will get? K minus that 4 k minus 8 is equal to 0. Okay, k minus 4 into k minus 2, k minus 8. You see 4 minus 8 is 32 we are getting. Minus 4 minus 8 is minus 12. In this way, please learn this. This is a shortcut method. Okay, so either k minus 4 is equal to 0 or k minus 8 is equal to 0. Again I am saying, if you find this is hard, do the middle term splitting. Okay, you will get this result only. So here k is equal to 4, here k is equal to 8. Therefore, what are the answer? K equal to 4 or 8. Alright.